Respiratory quotient. Now, respiration involves oxidation of respiratory substrates such as glucose and fats. Now, the oxidation of respiratory substrate results in a release of carbon dioxide with energy. When there is oxidation of the respiratory substrate, two things are released. First thing is carbon dioxide and the second thing is energy. Organic substances which are catabolized in living cells to release the energy are known as respiratory substrates. What are respiratory substrates? Well, they are organic substances, and these organic substances are catabolized in living cell, and when they are catabolized there is release of energy. Carbohydrate, fat and proteins, these act as the respiratory substrates. Okay, these are the organic substances when catabolized releases energy. Now, out of these three, carbohydrate is the most common respiratory substrate. Now, this respiratory quotient or respiratory coefficient is the ratio of moles of carbon dioxide produced is to moles of oxygen consumed during the complete oxidation of a metabolic fuel into carbon dioxide and water. Okay, when a metabolic fuel, that is your respiratory substrates such as carbohydrates or proteins or fats, when they are completely oxidized in the carbon dioxide and water, in that whole process, how many moles of CO2 produced is to moles of O2 consumed. That ratio is your respiratory quotient or respiratory coefficient. Now, moles of oxygen required and moles of carbon dioxide released, these two things, both of the things depends upon the nature of the respiratory substrate that is being broken down. How much oxygen will be consumed and how much carbon dioxide will be released, that depends upon the nature of the respiratory substrate that is being oxidized to release energy. Now, for carbohydrates such as glucose, the respiratory quotient is 1. Okay, RQ is equal to 6 mole of CO2 produced divided by 6 mole of O2 consumed. That gives you 1. Okay, you can see from this equation that is in the conversion of one glucose molecule, in the complete oxidation of one glucose molecule, 6 oxygen molecules are required, and this conversion produces 6 carbon dioxide molecule. So that is the reason why the respiratory quotient of the glucose is 1. Now, RQ is less than 1 when respiration is aerobic but the respiratory substrate is fat or protein. Okay, aerobic respiration, during the aerobic respiration of fat and protein, the RQ is less than 1. Generally speaking, the respiratory quotient for the fat is 0.7 and RQ value for protein is 0.9. 0.7 is the respiratory quotient of the fat and 0.9 is the respiratory quotient for the protein. Now let's consider one example of fat, that is palmitate. Okay, this is palmitate. It requires 23 oxygen molecule for its oxidation, and the complete oxidation of this palmitate gives 16 carbon dioxide molecule plus 16 water molecules. Now RQ, while considering this reaction, will be 16 molecule of carbon dioxide produced divided by 23 molecules of O2 consumed, and the value of RQ that you get is 0.7. Okay, so 0.7 is the value of the respiratory quotient for palmitate, which is an example of fat. Now the respiratory quotient is more than 1 in case of aerobic respiration of organic acids such as malic acid and oxalic acid. Okay, when these are subjected to aerobic respiration, then in this condition the respiratory quotient is more than 1. Let's consider the example of malic acid. This is malic acid. It requires 3 oxygen molecules for its complete oxidation, and when the malic acid is completely oxidized, it produces 4 carbon dioxide molecules and 3 water molecules. So RQ, according to this equation, is 4 mole of CO2 produced divided by 3 molecules of O2 consumed, and this gives the value 1.3. That is the reason why the respiratory quotient in this case is 1.3. Okay, the respiratory quotient of malic acid is 1.33, that is more than 1. For carbohydrates, the respiratory quotient is 1. For protein, it is 0.8 to 0.9. For oleic acid, it is 0.71. For malic acid, it is 1.33. And for oxalic acid, it is 4.0. Okay, these are some common substrate and their respective value of RQ.